So in previous session, we discussed the advantage of using array to have data processing. We mentioned that using array, you can store a series of data in memory. And because they are in memory, you can do the processing really fast without any user input and output, without any file processing. This is faster than the other options. And when you store data in the array, you can have a multiple processing over the same data set again and again. So these are the advantage of utilizing array. The downside of array is that because it stores in memory, when your computer is turned off or lose power, the data is gone. Then next time you will have no place to load it again. So for this reason, we usually store large chunks of data inside files. And when we run our program, we will open the file, read from the file, and read the file into array. So, and do processing inside the array, then write back to files on the processing result. This is a common pattern. But before we combine array and file together, there's one more thing to note, which is the sample program here. That because most text files consist of a series of rows. Each row is a series of string. For example, let me just type like roses are red. This is one sentence, one row in the file. And it consists of 3 words. And sometimes it's words, sometimes it may be a number like 1, 2, 3, 4, 5, separated by comma. So we call these tokens. The number one step in file processing is read. Once you read the row, you will need to break up the row into smaller tokens so that you can do further parsing. For example, roses are red, you will break it into roses are and the red with a period. Or 1, 2, 3, 4, 5, you will break it to as 1, 2, 3, 4, 5, something like that. But how do you process these tokens is based on your requirement. In like these roses are red, in natural language processing, usually you will remove the punctuation, remove uppercase, and convert these words into their original form. For example, roses will become remove the plural form, and R will be converted to B. And 1, 2, 3 numbers will be converted to integer or double, depending on your requirement. So these are the things you will be processing to tokens. But before you do the token processing, the first step, of course, is to read the row and break the row into tokens. So this sample question is about receiving a string of comma separated integers, like 1, 2, 3, 4, 5, like this here, from user input, then find the largest integer. For example, if the user input is like this, you should break it up into 1, 2, 3, 4, 5 and get the output of 5, which because 5 is the highest here. Now, how do you do this string parsing? There's a very useful method in string class called strings.split. String.split will split a string into an array of strings based on the argument you put in. This argument, it can be a space or it can be a comma. If you need to know further, you can Google Java string split for detail. And once you have the string array, you will have 1, 2, 3, 4, 5. Then you will convert these strings, smaller strings, tokens, into integer by using the integer.parseInt method. Okay, so let's start by creating a sample question class. Sample question parse string or string parsing. And let's create Java doc command first by copying this over. add indentation. And now let's create public static void main. Args. Now, first thing first, we will have an input. So instead of an input, let me just use a string s input equals to. Let's copy this over. Now, string array tokens will equals to input dot split. Now you can see split exactly if I do this comma, and ideally it should returns an array of 9 elements, 1, 2, 3, 4, 5. How do I know this is done correctly? Before I proceed to the next step, the best way to do it is do some system print. Let's print out the first element and see whether this returns the right number, 1. And it does. How about the fourth number, which is 5? Looks like it's correct, right? Now, we have this token. So let's do a for loop. We want to convert this token into an integer array. So let's do this numbers. And we need to define the numbers as the length of tokens, right? Because we want to convert every number in the tokens number to integer, in the tokens array to integer. So for int I equals to 0, I less than numbers dot length I plus plus. At this point, numbers has been initialized. Every element inside, however, is just 0. Now we are assigning value to it by using the integer dot parse int tokens I. We're assigning its value, the value based on the corresponding element in the tokens array. So here, let's also print out I. Token I, numbers I. Right, so we have the proper integer. Now what we need to do is we will use this array processing. Oops, you have this array processing get highest value, right? So we will use this. First, let's copy this class name dot get highest value. And let's system out the print highest value plus these numbers. And oops, highest value is 5. So apparently you can see that we are getting this split and we are using parseInt to convert one at a time. Now that's one thing you can see, that halfway through our development, we use system out print to print out the values that we are receiving. Same thing here. In the array processing, we are using system out print to print out each step and the values and then the variables value at that point, which we call states. So it's a very common practice to either use a system out print or using some file logging file. You save the information current state to file. Where we are, which step we are in, which loop we are in, what's the state, like what's the value here, and what operation we are in. Like if you have an if-else branch, which branch did you get into? These are the states and steps and the control flows that you will print out. Either you print out or you write it to a logging file. You write it to a logging file, you write it to a console, then when errors happen, you can go back to check. First of all, if there's no error, at least you can check to make sure your logic is correct and your program is running the same way you want it to run. If there's error happens, you can see where that error happens. And when error happens, usually it's not only because you make a mistake in that particular spot. It also could be that somewhere before that, 1 or 2 loops before that, the state is already wrong. So that's when log can be useful. You can trace back on the step what happened in that error when the error happened and what happened before the error happened. That can help you in debugging the Java code.